Science only deals with models, and any model is not equal to reality. Therefore, science is based on a straw man fallacy, like inherently, by design, okay? Nature says gravity, we say curvature of space-time. It's a straw man for nature. Greetings, this is Eugene the Philosopher, the greatest living philosopher after the unfortunate passing of Quentin Robert de Neyland, who has been the greatest living philosopher before me. Now, in this video, I want to talk about how science corresponds to the things it is supposed to describe, okay, to nature, roughly speaking. And I know we've talked about this quite a lot in many of my previous videos, like, for example, watch my video, What Physics Is and Isn't. I'm gonna link it in the description, and many others as well. However, recently, like a few days ago, I came up with a really interesting way to sort of spin it, you know, in a very clickbaity kind of way, which is what I'm doing in this video. And besides, like, all these points, I believe, are worth repeating over and over until my viewers would say, oh, stop it, brother, we've had enough of this already. We know that science only works with models. Stop it. Let's talk about something else. Or something to that effect, okay? So I'll keep talking about this. Now, this collective of Shiloh and Anastasia, right, Demystify Science, maybe you've heard about it, maybe you haven't. Pretty nice podcast. They organize their conferences, etc. However, like, the point I'm making is they have this expression which I really like. Maybe they've stole it from somebody, but I've heard it from them, so I'm giving them as my quotation. So they're saying, they have this saying of confusing the map for the terrain. And this is exactly what I think science is doing, and this is what they kind of indicate with this expression. It's when, like, you're taking theory about reality, aka a map, for reality itself, aka the terrain, you know? So, I love this expression as it exposes essentially a logical inconsistency of science itself as it is used today, namely in a very dogmatic way. Like, science today is very dogmatic. So this is exactly the kind of spin that kind of I want to make with this statement, that we are confusing the map for the terrain, we are confusing the models of reality for reality. Again, just like I've elucidated in my video about physics, that it works with models, it doesn't work with nature itself, alright? And the spin I want to give to it is that we are dealing with essentially straw manning of reality, if you think about this, alright? So what is a straw man fallacy? It's when I say one thing, but in an argument with me, instead of refuting my point, the literal point I've said, you're making up sort of like a weaker version of my argument, called the straw man, right? Kind of a straw version of myself, like a voodoo doll or something. And you attack this, like a weakened version of my argument instead of my actual argument, okay? So this is what straw manning is, and I believe, and hopefully you can see it right now, how science is actually strawmanning reality itself, alright? At least the science, like what they call hard science, you know, physics, roughly speaking. And everything that is built on the model of physics. Pun intended, actually, speaking about models, right? So, this is a strawman fallacy of science. And science is built on a strawman fallacy, essentially. Like, nature says gravity, and we say, huh, did you just say curvature of space-time? Well, this is a straw man, right? So gravity is the terrain, curvature of space-time is the map, right? And we study the curvature of space-time instead of studying gravity. We are straw manning the reality. We're dealing with a straw man argument instead of the real argument, right? Or think about, I don't know, the Lesage pushing gravity, you know, like Jim Wenninger keeps tagging me on Facebook with his posts about pushing gravity idea. I don't mind, to be honest. Or again, a simple Newtonian formula that we have, like a, you know, like solid balls of stuff and they just attract according to a certain formula. Or Machian inhomogeneity of, you know, matter distribution in the universe. Like, these are all straw men, plural, for gravity, okay? For what nature does. So yeah. That's kind of the point of my video, really. That science, at least to the degree it's modeled after physics, as kind of the main science, the most fundamental one, right? It deals with straw manning of reality. Nature says one thing, we substitute it for another, for a straw man. aka a model, aka a map. Okay, so we confuse the map for the terrain. We study the map, not the terrain. And it's by design, and you can't really do anything else. Because again, science is based on mathematics, and mathematics itself is a map, you know. There are no, again, watch my old video, like, how do numbers relate to reality or something to that effect. I'm gonna link it in the description. Where, like, I show how mappy it is, you know, with respect to the actual terrain of the real world. So yeah, all of these straw men, plural, or maps can be, of course, useful but as a tool, again, not as a path towards some sort of ultimate truth. So science, by design, again, cannot ever deal with the truth because it's not even dealing with reality in the first place. It's dealing with a straw-manned, reformulated version of reality, if you wish, okay? Well, then you might say, well, how about we kind of get rid of straw men and study the nature, aka the reality, aka the terrain itself, okay? Can we get raw data, you know? That's a kind of a frequent sentiment, I guess, in the sort of various alternative science communities. Like, let's just get raw data and then we can maybe come up with a better theory, with like more, you know, truthful theory. But the problem is there is no such thing as a raw data, you know? Like, again, look at the history of positivism. When they arrived eventually, like roughly at the beginning of 20th century with Husserl and people like that, they've arrived at the necessity, like, okay, we need protocol sentences, what they called, okay? So we wouldn't say, in this experiment, we measured the current strength like 5 amperes. Instead of that, we make a protocol sentence, that's a technical term from their philosophy, which would say something like, the arrow of our ampere meter kind of shows 5, okay? But, like, it doesn't matter. Like, even if you try to dissolve, like, sort of boil it down to these very simplistic, like, naively understood factual sentences or statements, it doesn't matter, because even the very design of your experiment, the very design of your devices, it all is based on some sort of theory, some sort of model, some sort of a straw man, you know? Like that, this is the biggest problem. So we are kind of doomed. We are like sentenced, I don't know, to be dealing with only the models, unfortunately. Like, you cannot even build an experiment without a theory, okay? Because you need to have a theory of how, let's say, different components of your experiment work, right? Or otherwise you wouldn't even be able to build it. Like, I have this example, again, like we're generally right now in this segment talking about the impossibility of getting raw data. So I can give you actually a very actual, in the sense of like, as a pressing issue, example from my own like communication with some of the alternative scientists. Like let's say there is a research in cold fusion, you know, like transmutation of elements or some stuff like that. And you might know that one of the problems with these experiments is their poor reproducibility. So as a raw data, you know, what I would like me, Eugene the philosopher, would like them to give me is the time, the exact time when they made the experiment. Because in my paradigm, for example, poor reproducibility means you're missing something. And my idea with regards to that is that you're probably missing the time when you're doing the experiment. However, all of these researchers, all of these experiments, maybe not all, but the absolute majority of them work under the ubiquitously usual assumption in regular physics that all the moments in time are identical, and therefore there's no point in even documenting the moment of time when you're doing the experiment. You see what I'm saying? They already have a model of reality in which moments in time are identical. Therefore, a moment in time when the experiment is made is not considered raw data by them. However, under my, let's say, paradigm, where I assume that moments in time, for example, might be different, I would really like to see the moments in time when they're making their experiment. So maybe there would be something there. Maybe we'll see some signal there. Like, I don't know, during the full moon, the experiment works and all the other days it doesn't. You know, something like this. But why not? Like, you know, if we're dealing with something new, how would you know, you know? But again, I'm telling you this story, this sort of personal anecdote, to kind of explicate my point that there is no raw data, you know. What is raw data for me with my model, even though it's already oxymoronic to speak about raw data according to some model, is not raw data for them according to their model, right? Like we can talk about like the philosophy of moments in time being different, about like implications, blah blah blah, like the conservation of energy. Like that's not the point I'm making. I'm making a point that there is no raw data, and hopefully I was able to show it to you. Like it's always informed, even the very construction, the very design of the experiment is always informed by some model and therefore by some version of strawmanning of reality. So we finally kind of came back to our point. By the way, speaking of these protocol sentences, watch my video Nature of Knowledge, and also I have a whole video dedicated for design the experiments kind of thing, and how many theories are actually implicitly contained there. Watch my video Analyzing the Double Slit Experiment, I think is how I called it. All right. Let's return to the topic of the maps, all right, with respect to science. So Jorge Luis Borges, the writer, has this interesting piece called On Exactitude in Science, okay? I think the original is in Spanish, so there's some other types of translation, but On Exactitude in Science is good enough, a translation. That's the title. So it says, it talks about some fictitious country where cartography, we're talking about maps, right? So cartography became so exact that the map they have, the map of their country they have, is actually equal to the terrain of the country itself. Which, like, philosophically, it opens up a can of worms, kind of, right? Because it's not hard to see that a map which is exactly equal to the terrain is useless, right? Because you just, well, there's your terrain. Why would you need a map which is just a copy of your terrain, essentially? You have now two countries, ultimately, right? So this map is just as good as the initial country itself, in the sense that, well, it's not even a map anymore, right? It's so exact that it's useless, right? So here, like, it shows us, I think it's a brilliant example to show us how one of the types of theory of everything, which is definitely, well, at least supposedly possible to build, you may build such a theory of everything in science which would be so complex, it would describe everything, literally everything, but it would be just as complex as the world itself, right? And in this respect, just like in Borges's piece, the map was just as complex as the terrain itself, and therefore useless. So this type of theory of everything, which would be essentially just a copy of the universe, right, is also useless, because, well, why would you need two universes? Like, this is the universe we're trying to deal with in some simplistic, hopefully, kind of way. So we need a map. We don't need a copy of our universe, right? We just need a map that allows us to orient in this universe, instead of just copying the universe itself. So this is one type of theories of everything, right? And the second kind, again, we're staying on the map topic, is the diametrically opposed theory of everything, is to have a map so blurry that you can't distinguish any object there. So in this sense, it's also a theory of everything. It's also a map of any terrain, because, well, any terrain can be described by it, because it's just so blurry that, like, this could be a mountain, this could be a river, this could be a city. Like, I don't know, you know, and if I see a mountain or a river or a city, well, okay, the map described it, but unfortunately it was so vague and blurry that, you know, it was no use for me, right? It was useless. So these are kind of the diametrically opposed, how should we say it, ends of the spectrum of the theories of everything, right? One is so exact that it's just a copy of the universe itself, and therefore useless. And the other is so blurry that you can't possibly use it for anything, because it describes literally everything, but in so poor detail that it's, again, useless. Again, I've already gave you my own example of such a theory of everything, which is very blurry. I said that, like, literally two words. Things exist, right? That's a theory of everything, because it literally describes everything. This lamp exists, this camera exists, I exist, right? You exist. But, so what, right? It's absolutely useless. But it describes everything, right? It's a theory of everything. And on the opposite end of the spectrum, we have just, okay, to describe how this electron flies, let me make a copy of the whole universe and look where electron flies in this copy. Then I say, okay, it flew there, then in our universe it would also fly there, right? And that's also useless, understandably so. And by the way, I want to reference the Blackadder Goes Forth, the comic series. I'm going to share a clip with you where they have also kind of the demonstration of these two theories of everything regarding maps, in particular, you know, maps of World War I. Which is so funny, I just couldn't miss it, all right? Anyway, yeah. So, well, we're kind of gonna wrap this up very soon, I guess. Anyway, let's talk about models a little bit, and then we'll wrap this up. So every model obviously has its limitations, right? Every strawman, like, is useful only to a degree, but otherwise it's kind of useless. But in any science, we only have models, again. But once you embrace that, this is sort of like a bit of a pompous / pathetic point I wanted to make, because, well, it's moralistic, right? So I've been thinking, like, maybe my next video will be about this sort of governance and division of people, you know, like divide and conquer type of reasoning regarding history, regarding religion. So I was thinking about making some about science as well. Like, you know, all these arguments, like this theory is so much better than this theory, like electric universe is so much better than blah, blah, blah. Like Pierre-Marie Robitaille's solar model is so much better than the gaseous solar model. And it just is used, unfortunately, to divide people. And this is kind of my problem with it, right? So the pathetic / pompous point I kind of want to make is that in science we only have models, and once you embrace that, you can no longer become a partisan, you know? You can no longer say, okay, my theory is correct, every other theory is wrong, right? Like, you can no longer say that you have the truth, you know? Again, returning to my point about physics and also my video, when physicists apologized for Galileo, like, remember what I call the Galileo's curse. It's like when you think that your model is the truth, basically. It's this sort of uber omega arrogance, right? So you lose that once you realize that everything is just a model, all right? And you kind of just become really calm in this respect. So yeah. So any model might be useful in some aspects and useless in some others at the very same time. And for example, like wave-particle dualism is the perfect example, because it's like a very, very ubiquitous, very well known. So we have two mutually exclusive maps of the same terrain, right? So, and both are useful in some context, but again, they're mutually exclusive. Just like if you think about maps themselves, you can have like a political map, a map of the terrain, you can have like a geological map, I don't know, you can have a map of biomes, like, I don't know, make up your own type of map, and you can have it, right? So yeah. So one map, for example, the particle picture of light and matter, right? It helps you deal with absorption or emission really easily, for example, right? Which is where it was used in the first place in photoelectric effect, right? However, other map, like the light and matter are waves, right? It allows you to deal with this phenomena like diffraction and interference, which the particle model fails to do, right? Etc., etc. So, but both are just models, right? Yeah. So any theory in itself is thus, and I'm kind of vaguely referencing my previous video, but what I want to say is any theory is the message, in the sense that it may be used to, again, divide people and provoke some unnecessary, honestly, conflict, right? So yeah, I'm referencing my video Medium as the message now. Again, watch the link in the description. So yeah. It's like a religious sect, you know. Any theory can be used as a religious sect to divide people. But fundamentally, it's okay, you know. We have freedom of conscience, at least supposedly, you know, hopefully. Yeah. And, yeah. So science fundamentalists, you know, people who say that my science is better, or even better, they say the science, you know, as if there is only one model possible, period. They really behave just like religious fundamentalists who say that my version of God or whatever, you know, spiritual world is the only one possible, and you have to die or something, you know, like it's not good. And the same is people who advocate for the science, as if there was some the science, you know, instead of sciences, plural, you know, models, plural. Again, it's a Galileo's curse. All right. It's not good. That's what I'm saying. But then again, we'll probably talk about this in the next video. I'm still bargaining with myself whether I want to make it or not, because again, it's a little bit pathetic. Okay, so concluding this video, what have we talked about? That science only deals with models, and any model is not equal to reality. Therefore, science is based on a strawman fallacy, like inherently, by design, okay? Nature says gravity, we say curvature of space-time. It's a strawman for nature, all right? Hopefully, you can see that. Any model is a strawman, and therefore, science, since it deals with models, it deals with strawmen, plural. And as such, any science is based on a fallacy. It might be useful, it might not be, but it's useful to understand that it's very doubtful, at the very least, that you can arrive at some sort of ultimate truth through fallacy. Only by some miracle. But you don't believe in gods, do you? Thank you for watching. The eons are closing. If you wish to support me, please consider joining my Patreon. That is patreon.com/philosopher. See the link in the description. Or if you have a scientific theory of your own and you'd like my help in developing it, please join my alternative science coaching program, also available through Patreon.